Hello students. In this session, we are going to learn about Lasso regression and ridge regression. For that, you need to understand the concept of bias and variance. Bias. Bias is the difference between the estimated and real output value. It basically means that if you have a value which is 10, which is an observed value, and your model gives an output as 12. So this 10 and 12, if you see, there is a difference of 2. So this difference is called as bias. So the prediction and the actual has got some difference, right? Now, if the bias is getting higher and higher and higher, okay, that basically means that the model is not able to make predictions in a correct manner, and it has not learned from the data, or it was not able to identify proper pattern from the data, and therefore it is giving high bias. Now we have variance. Now variance is a value that declares spread of our data for a given data point, which basically means that if our model has got high variance, then this means that our model learns from the training data set, okay, and it learns in such a way that whenever you are going to give some input from the training data set itself, it is perfectly going to give you the output. But if you give some new input, then basically it won't give you a good output. So this basically means that the model has memorized the observation instead of finding the pattern that can generalize the model from the testing data. So memorizing is not a good concept. So finding out the pattern was the task of the model, so that it did not perform. So these are the two terms basically, which of one is called as bias and the other one is called as variance. Now what do we want? We actually want to minimize the loss function. Now you will think that what exactly is loss function? Loss function, in very simple terms, a function which basically identifies the loss or difference between the actual output and the observed output. That is the loss. Or sometimes we call it as error function also. So here I am calling it as loss function. So we want to minimize the loss function. That means the value should be close to 0. Now, if the value is very close to 0, then the model might become overtrained. Okay. And if the value is very far from 0, then it might be a possibility of underfitting, insufficient learning. So both the cases are challenging. So therefore, we are talking about a generalized model. So what does a generalized model means? Generalized model means that it is not memorizing from the training data, and it is not also giving a random guessing by insufficient learning. Okay, so insufficient learning, bias, and memorizing means variance. High bias, insufficient learning; variance, over learning. Okay, so overfitting. So we want to save ourselves from these two basically losses. Okay, so now we have two approaches here. One is basically lasso regression and another is ridge regression. So lasso regression, it basically uses L1 penalty, and then it tries to ignore some attributes. Okay, so we call lasso regression as the L1 regularization also, where it tries to ignore some of the parameters. Parameters means if you have input data, you have x1, x2, x3, x4. So it would try to do what? Minimize. Let's say out of 30 parameters, it will take only 10. It will take only 12, 15. So it has limited the number of attributes or the parameters. That is what it does. Okay. So therefore, this is first approach of lasso regression. Okay. Now here you can see we have implemented lasso regression on Boston dataset. So From sklearn.linear model, import Lasso, and similar way import Ridge also. And we have already seen on linear regression. Now, once we implemented at that particular time the kind of observations we get, so we get that here we have lasso, the star symbols, okay, then lasso with diamond symbols, lasso with lambda symbols. You can see all of them here, and you can see the linear model also. So here we have a regularization parameter which is lambda over here. When you keep the lambda value 0.01, you can see the positions of this star. When you keep them the value as 1, you can see that a bit of deviation, okay, from the stars, the blue ones. And if you keep it as 100, then you can see that how they are basically being put. And if you keep run the linear model, then you can see the linear model, how basically linear model are. So here your observation will tell you that linear model and lasso, which is near to 0, lasso where lambda is near to 0, they are almost having similar behavior. When lasso, we are minimizing it to 0, near to 0, and linear model, there basically you can see they have similar behavior. Okay, now let me talk about the ridge regression also. So ridge regression now tries to find some parameters. We can call them as beta parameters, and these parameters will have the smallest variance. So it is also working on attributes. This is called as L2 regularization or L2 penalty. So it is trying to find out some beta parameters which are having smallest variance. So here you can see in this particular case we have implemented ridge, and let me execute this. And now what sort of output are we getting here? So here you can see when ridge the lambda is 0.01, then it is very similar to linear model. And when you can see it is 100, then in that case it is different from the linear model. So what sort of observations are we able to get from these two graphs? Now, here we have a concept of underfitting and we have a concept of overfitting. Two concepts are there. These two things may happen whenever we are making our machine to learn. We can see here that that is happening over here also. Okay. Now, overfitting happens when basically we have increasing the error rates for samples in the testing set. Okay, overfitting. So training test, the output will be perfect, but for testing test set, the output will be wrong. Now underfitting, it incurs higher errors due to insufficient learning or training. So underfitting is going to give bad outputs at all the cases. Okay, whatever may be the case. In this particular case, the number of attributes in ridge regression, they have not reduced. But in case of, if you see, the value for lasso, the number of features have decreased. So lasso basically makes the feature selection, and when basically we are giving the high value for, it is shown as lambda here or alpha, then scores were low. And when basically scores were low, that reduced the or eliminated the attributes. Okay, fine. Now in case of overfitting, if we talk, we reduce the effect of overfitting. How? By decreasing the alpha parameter. So if we reduce, so if you see this particular diagram, so if you are basically making the regularization parameter very closer to 0, it is actually giving you an output similar to what linear model gives. Okay, so these two algorithms, the ridge regression and the lasso regression, they help us to regularize, they help us to generalize the linear regression model so that it doesn't get into the problem of overfitting or underfitting. I hope you were able to understand the concept and try to execute and interpret what we have discussed just now. Thank you.